Greetings, everyone. I would like to thank you for giving your time and interest in joining this informative webinar. In today's session, we are going to be exploring on how DDI solutions, DNS, DHCP, and IP address management can play a critical role in one of the most significant and challenging shifts happening in manufacturing right now. That is, the convergence of operational technology and information technology networks. This session is designed for manufacturing IT teams, network engineers, operation managers, and anyone responsible for keeping the network infrastructure of a manufacturing plant secure, reliable, and scalable. And if you are here because you want to understand what DDI solutions are, how they work, and how they can genuinely improve the network efficiency, security, and operational control, stay with us till the end of the session because we are going to cover all of it. So let's get started. To introduce myself, I'm your host Vikram Aditya, product expert from ManageEngine. I collaborate with the ManageEngine DDI Central and Cloud DNS marketing teams, and I'll be talking about the critical network services, DNS, DHCP, and IPAM, and how much vital they are for increasing the operational efficiency, strengthening the security, and providing robust control over network activities and complete transformation in the network infrastructure of the manufacturing sector. Here's how today's session is structured. We'll start by stepping onto the factory floor and taking a closer look at how manufacturing networks are actually built, what IT/OT convergence means in practice, and why it creates the network challenges it does. We're going to spend real time here because understanding the environment is everything. From there, we'll look at the threat landscape because manufacturing has become the most targeted sector for cyber attacks globally. And a big part of that story sits at the ID/OT intersection. And finally, we'll explore how DDI Central addresses these challenges heads on through centralized management, intelligent segmentation, automation, DNS security, and more. By the end, you'll walk away with a clear picture of what IT/OT convergence demands from your network infrastructure and exactly how DDI Central meets those demands. Start where the story really begins. For many years, manufacturing networks existed in two separate worlds. On one side was operational technology, OT. This included many machines like PLCs, SCADA systems, sensors, robotic arms, and conveyor systems, the equipment that actually runs the production. These systems usually specialized protocols designed for reliability and real-time control, not for internet connectivity. And to stay secure, OT networks were often completely isolated, meaning they weren't connected to other networks at all. And on the other side was the IT network, business systems like ERP software, computers, email, and etc. These used standard network net technologies like IP, DNS, and DHCP, and were managed by IT teams. For a long time, these two systems operated separately, and that worked well. And then the Industry 4.0 changed everything. Manufacturers began connecting OT systems to IT networks to gain real time visibility and control. This allowed companies to monitor production remotely, predict equipment failures, optimize supply chains, and improve quality using data and automation. The benefits were huge, but so were the risks. By connecting OT to IT networks, companies didn't just gain efficiency, they also exposed the OT systems to cybersecurity threats. Many OT devices were never designed to handle modern network attacks. Some run outdated software and can't be easily updated, yet they are now connected to the networks that may even reach the internet. This is the challenge of IT/OT convergence, and it has become one of the biggest issues in modern manufacturing sector. Let's look at where the industry actually stands. According to the 2024 study by Telstra International and Omdia, based on a survey of over 500 manufacturing technology executives, it shows a major shift. 70% of the OT systems are expected to be connected to corporate ID networks, up from 50% today. This significantly increases the attack surface. However, security readiness isn't keeping up. Only 90% of the manufacturing firms are considered advanced in securing their IT/OT environments, and just 45% felt prepared to handle cyber threats across the connected systems. Manufacturing has become the most targeted industry for cyber attacks globally, and this isn't new. According to No B4's 2024 report, it has been the top target for ransomware for 4 consecutive years. In the quadrant 2024's quadrant 4 alone, Dragos reported that manufacturing accounted for 70% of the ransomware activity across industrial sectors, 424 out of roughly 600 incidents. The situation gets worse. Confirmed data breaches in manufacturing rose by 89% from 2023 to 2024, and nearly half, that is 47%, involved ransomware. The SANS 2024 ICS OT survey also found that about 50% of the attacks on OT systems were originated from IT network breaches. So, in other words, attacks often start in IT and then spread into the other factory environments. So, why is manufacturing such a prime target? Because downtime is extremely costly. When production stops, losses build up immediately, impacting output, supply chains, and contracts. Attackers understand this, which is why manufacturers are often pressured to pay quickly. Let us go through a real life incident that happened recently. In March 2019, Norsk Hydro, one of the world's largest aluminum producers, was hit by a major ransomware attack that is still widely studied today. The attack actually began months earlier, in December 2018, when an employee opened a malicious email that appeared to come from a trusted customer. The malware allowed attackers to quietly move through the company's IT network, thus gaining access and mapping systems over time. And on March 19, the attackers launched the ransomware across the entire network all at once using the company's own domain controllers. Because the company's OT systems were connected to its IT network, the impact reached the factory floor. Some plants had to shut down completely, while others switched to manual operations. The company lost about $71 million and took months to recover, but they chose not to pay the ransom. And here's the key takeaway from this story: the attack didn't start in OT, it started in IT network. But because the two were connected without strong controls, it spread into critical production systems. This is the real risk of IT OT convergence, and exactly the kind of problem solutions like DDI are designed to prevent. The diagram you see on screen shows how a typical manufacturing company's private band is structured. Each location, whether it's a production plant, warehouse, showroom, or remote site, has its own local network, all connected to certain private cloud through an SD-WAN backbone, supported by high-speed networking infrastructure. Each site also has the backup connections to ensure operations continue, even if the main link fails. At the center is a private cloud hub that manages network control, security, and connectivity, along with protection at the internet edge. Now, on paper, this is a strong and reliable setup. But when the number of locations grow, the number of devices also increases, and so does the complexity increases. More sites means more devices, more IP allocations, and more DNS traffic that needs to be managed and secured. And when you add OT systems into the network, like PLCs, SCADAs, and industrial sensors, the challenge becomes even bigger. Now, it's not just one network to manage, but two, IT and OT, and that are increasingly connected. And this is what a typical single LAN network looks like. And notice that DNS and DHCP servers here are managed individually in isolation from the rest of the network. That means for every configuration change, every policy update, every troubleshooting task, the admin has to go into each server separately and now scale that across dozens or even hundreds of branches. The admin burden alone is enormous. And when you're manually managing everything, something always slips. Like, for example, a misconfigured server, an unmonitored IP range, a rogue device. These are the gaps that attackers take advantage and exploit. So, what does it take to manage and secure a converged IT OT environment at scale? The main challenge is visibility and control across both IT and OT networks. IT teams need to see what's happening in OT networks, and OT teams need consistent network policies, all without affecting the real time performance that production systems depend on. At the network level, this comes down to managing the three key components: DNS, which helps devices find and communicate with each other; DHCP, which assigns IP addresses and controls the network access; and IPAM, which is IP address management, provides a clear view of all devices on the network. In a large manufacturing setup with thousands of devices across multiple plants, managing these manually or with separate tools is not practical. A single unified platform is needed, and that's where DDI comes in. DDI stands for DNS, DHCP, and IPAM. And a DDI solution brings these three core network services together into a single management platform. So instead of jumping between separate tools, network admins get unified visibility and control across the entire network from a single place. With the DDA in place, the admins can discover and manage DHCP scopes across all sites and IT OT environments, dynamically assign IP addresses to hosts, enforce DHCP fingerprinting policies to identify and classify devices based on their type, manage DNS zones, domain views, and DNS records, set up and enforce DNS security policies, analyze real time DNS query traffic, review DNS and DHCP audit logs for compliance, and manage dual stack IPv4 and IPv6 address inventories. All of that in a single window. So, no more switching between individual tools for individual service, and no more fragmented visibility across both IT and OT networks. And this is the main foundation. Now, let me show you how ManageEngine has built this into a purpose built product, DDI Central. ManageEngine DDI Central is a purpose built DDI solution, a centralized platform that unites DNS, DHCP, and IPAM for improved management and security across manufacturing network operations. It manages your existing Linux-based IAC Bind 9 and IAC DHCP installations and can set up new DNS and DHCP clusters. And it supports Microsoft Windows DNS and DHCP clusters as well. For the rest of this session, we'll be going through how its features address the specific challenges of converged IT/OT manufacturing environment. Think about what it means to have every DNS and DHCP cluster from every plant connected via SD-WAN, IPMPLS, VPN, and even dark fiber cables, all visible and manageable from a single place. That's what DDI Central offers you. When you onboard your branches, DNS and DHCP clusters, DDI Central discovers all configurations at a granular level and organizes them in a clean, intuitive UI. You get real-time data, visual summaries, and the ability to make changes across any cluster without having to manually go through each server. Now, let me walk you through a real world scenario that shows exactly why this matters in a manufacturing environment. In a typical facility, the IT side includes employee systems, ERPs, MES, and business applications connected to corporate network. On OT side, you have PLCs, SCADA systems, robots, sensors, and IIoT devices. Over time, these OT systems have been connected to the same network as IT, either intentionally for modernization or gradually for remote access. The rest is a converged network, but often with inconsistent segmentation. Some OT networks are isolated, others are not. IP management is manual and there's little visibility into OT devices. Now imagine a new IIoT sensor is added to the production line, and when it connects to the network, gets an IP address and starts communicating. The key questions arise. Which network was it placed in? Is it properly isolated from critical systems like ERP? Or is it even tracked in the IP inventory? In many environments, most of these questions are unanswered, and an untracked device in a converged IT/OT network can become a serious security risk. This is where DDI Central comes into play. So here in DDI Central, it provides a cluster-based management where you can able to view all the resources of DNS and DHCP services all in this single dashboard. Whether the total number of servers that you added in DNS, the total number of domains, and the total number of queries received for the domains, the total number of subnets and their utilization percentage, and the total number of services that are up and down, all all of them in the single window based on the cluster you have selected. And here you can able to select the cluster from which you want to view the data, and you can have both grid view and list view of the clusters. And if you want to add a cluster, you can click on add cluster and provide the name, the type of OS you want to select, Linux, Windows, or cloud observability, and the service, DNS, DCP, or both, and the site you want the cluster to be associated with, which we'll discuss in the upcoming slides. Side, there will also be data about the memory usage for CPU, disk, and memory usage with tabular column value and a graphical representation for visual summary. This setup provides a contextualized network visibility for faster issue detection and troubleshooting, and real-time health monitoring for DNS and DHCP services are available for admins to easily monitor and manage. Role-based access controls, also known as RBAC in DDI Central, allows you to grant access to individuals in the organizations based on their respective roles. So here, if you go to users and if you want to add a new user in the network, click on add user. Here you can provide the basic details such as name, the username, email, password, and the TOTP. And here in the role section, you can able to select the role you want assigned for the user based on their hierarchy and responsibility. In RBC, we got four roles, two primary roles, that is admin and operator roles. The admin role have access to all the data, configurations, policies, and settings, while the operator role have tailored access to specific department and their configurations. While the other two roles, that is audit and guest role, they're only for visualization and auditing purpose. They won't be granted any configuration accesses. Permissions can be limited on cluster based and service specific, whether DNS or DHCP, and even both, and zone level for every individuals based on their hierarchical roles. By providing this flexibility in permission assignments, DDI Central ensures that individuals have just the right level of access to perform their tasks effectively, while maintaining security and minimizing the risk of unauthorized changes. Manufacturing facilities rely on a wide range of connected systems, that is, PLCs, SCADA platforms, AGVs, surveillance systems, etc. With such a diverse mix of OT and IT devices sharing in the same network, IP conflicts and unplanned distributions can bring production lines to a halt. Across a multi-site manufacturing enterprise, this can be centrally managed in using the DHCP scope manager in DDI Central. Admins can assign DHCP scopes for production floor devices, industrial controllers, mobile OT assets, and all the OT devices by production zone, factory floor, plant location, based on their specific department, all from the single unified interface. So every device always lands exactly where it belongs on the network, securely and without manual intervention. Now let's see how DHCP scopes can be managed within the DDI Central application. So here you can able to access and configure all the DHCP resources such as subnet, static subnet, shared network, and client class, which we'll discuss in the later slides. In subnet, you can able to create subnets by providing the network address, the prefix range, and you can able to calculate the prefix range through this subnet calculator and get their subnet based details such as net mask, broadcast, and etc. And you can enable failover when you need to implement failover mechanism and select the failover DHCP server. And you can assign this specific subnet whether on a global level or under a specific shared network. And you can provide a specific VLAN for this subnet, which we'll discuss in the next slide. And the same applies for the static subnet. Here you can provide a static subnet that can be utilized for static static reservations, fixed reservations by providing the network address, prefix range, and the specific range of the subnet, and add a VLAN. And in the shared network, when you create a shared network, you can able to group all the subnets you've created under a shared network and apply a specific and common DHCP option or custom options to all the subnets under this shared network. In manufacturing, standards like IEC 62443 and NIST cybersecurity framework don't just recommend network segmentation. They strongly emphasize it as a core security requirement. VLANs are the key way to enforce this separation at network level, and DDI Central makes it simple to implement and manage. You can able to access VLAN by going through the IPAM section and selecting VLAN and select Add VLAN. Here you can create a new VLAN by providing the VLAN ID, name, description, and assign it to the subnets you have created, whether subnet or static subnet or unmapped subnet. And you can able to select them the specific subnet you want to associate the VLAN with. Now, what VLAN does is that it helps in narrowing down and creating an isolated communication between the DHCP servers and specific devices that are need for IP allocation. For example, VoIP phones require instant connection when they enter the network, and so their network requests shouldn't be interrupted by other devices' requests. So when you assign a VLAN, their requests will be isolated and the communication between the server and those devices will be compartmentalized, thus preventing the IP allocation from disturbance and interruptions. This helps prevent other devices in the network disrupting the IP allocation process. In a live manufacturing environment, an IP conflict can disrupt a critical system and halt production mid-process. Real-time IP inventory visibility is what prevents a small network issue from turning into a costly operational shutdown. And that's where Manage IP comes into play. Here, you can view all the IP addresses under the selected subnet you selected here under the specific cluster that you've chosen. You can choose the specific cluster you want to view and the subnet under which you want to view all the IP addresses and their status, whether they are available or active or designated through this tabular column and also in this graphical representation where the total number of IPs in the subnet and their status will be marked. And here you can view the total subnet usage of the subnet you have selected. By clicking on this yellow icon, you can select the ping option, telnet option, and associate a DNS record to the specific IP address through DNS relation option. This is for the IP addresses, the subnets that are associated with the cluster. And if you want to view the IP address inventory of unmapped subnets that are not associated with the cluster yet, here in the unmapped section, you can able to view them. The same type of data will be displayed in the tabular column and in the graphical representation, except you can able to view the site under which the unmapped subnet are associated. Network segmentation can also be done on a DNS level with the help of domain views. So domain views can be accessed in the DNS section. By clicking on the views section, you can enable view to the cluster and a default view will be created. And if you want to create a custom view, you can select the add view and provide the name and the clients you want to match to resolve for a specific DNS request. Now, what happens is that DNS view will have two different view match lists, internal view and external view. Internal view is only for the internal staffs and employees who can only access the confidential data of the organization, while the external view provides customer-facing data for the outsiders, such as stakeholders, customers, etc. Now we need to differentiate the network resolution for a same web page, but having different data and information. That's where DNS view comes in. And this is not just in outside and inside separation. You can also implement it on a inside network department specific. Say, for example, you want to separate a specific department from resolving accessing the data through this DNS resolution. You can only provide the match clients you want to resolve here, and that way that department will be segmented from the DNS resolution. DDI solutions provide built-in logging and reporting to support compliance with regulations such as GDPR, HPAA, PCI-DSS, and ISO IEC 27001. And DDI Central records detailed audits for every action across DNS and DHCP objects, allowing admins to generate compliance reports for specific subnets and zones only. This targeted reporting reduces audit effort, time, cost compared to full network audits. The audit in DNS can be accessed over here by clicking on the audit. Here you can view the audits based on filter specific, such as domain specific, record specific, and the action specific, whether the domain is created or updated, deleted, and user specific and date and time specific. Here you can get a graphical representation on the audit, and a tabular visualization of what action is implemented and by who and in what time and on what domain. The same way you can view in the DHCP section. Here on scope level, action based, user based, and data time. And in the tabular column, you can see the action implemented and by who and on what time. This saves time and cost for auditing purposes and compliance purposes. According to across a manufacturing environment, untracked devices and shadow IPs can appear on the network without anyone noticing. And in a factory setting, an unknown device can become a serious security risk or disrupt operations. The IPAM tower ensures complete visibility, so no device goes unnoticed. Here in the IPAM tower view, you'll get three different types of view. View for site, cluster, and supernet. And under each view, you'll get three different types of view. That is table view, tree view, and cards view. Now, what this IPAM tower showcases is that all the subnet, static subnet, and sites that you've created and the clusters you've assigned with supernets, subnets, static subnets you've associated with the site, all can be viewed here. And you can create a site under the site view by providing the name and the region you want to associate and the cluster, the subnets you want to associate with here. And you can directly create a subnet from here and associate it with the site, which redirects to the create subnet page. The same way here in the clusters, you can view the clusters that are associated with the site and the domains they have, the supernets, all the DNS and DHCP specific data, along with the IPv4 and IPv6 utilization values. And the same applies to the supernet view. You can view the data of the supernets that are created and the subnets that are managed by DDI Central and the subnets that are imported and yet to be associated with a cluster. Those are called unmapped subnets. You can import your existing IPAM data, the subnet supernets, by clicking on the import option, where you can import the IPAM data through CSV or XLSX file, and you can export the existing data within this dashboard through the export option. And by clicking on the sync all cluster option, it updates the existing data so that no outdated data will be existing here. So it will be on a constant update. In manufacturing, downtime means halted production, equipment risks, and costly delays. A primary server going down shouldn't bring your entire plant network and operations to a stop. That's where the failover mechanism comes into play. So here in the DNS, when you're creating a domain, you can implement the failover mechanism by providing the primary and the secondary server which you want to provide for the failover mechanism by selecting them here. And same applies for the DHCP. As we saw, we can enable the failover DHCP for a subnet that you're creating, and you can select the DHCP server you want to utilize for the failover mechanism. So what happens is that the primary server takes care of the DNS or DHCP service at the main level. They are responsible at the first place. But when when the server goes down, or when there's a network disruption in scenarios where the primary couldn't continue the service, the secondary takes the place of primary and continues the service until the primary server comes back to service. The problem gets resolved. By that, there won't be any network inconsistency or network downtime or delays for clients as well as the organization's network. synchronizing DNS, DHCP, and IPAM, DDI Central acts as an automation hub that simplifies end-to-end network operations. Key processes that can be automated that include automatic IP assignment through DHCP client classes, which can improve efficiency and preventing IP exhaustion or wastage, where you can also dynamically update the DNS records automatically through DDNS whenever the IP address change, so thus ensuring continuous domain accessibility. Automatic detection and resolution of IP conflicts along with real-time IP inventory updates to maintain network reliability and prevent downtime. Scheduled DHCP scopes, DNS records, and automated reports that enable a set and forget approach, helping admins plan network changes while gaining insights into subnet capacity and DNS query analytics for better IP utilization. An unauthorized device that blends into your network reaches a sensitive subnet can cause a serious damage before anyone notices. Fingerprinting ensures every device is identified and classified the moment it joins before it gets anywhere it shouldn't. Now, let me provide you a use case scenario to explain this better. Now, imagine an automated guided vehicle AGV of a manufacturing plant moving from sector 1 to sector 2. This isn't just a machine, it's a connected OT device. It communicates with control systems, sends data, and relies on the network to function. In sector 1, the network already knew this AGV. It was identified, classified, and given the secure IP address from a dedicated OT pool. Everything was controlled and predictable, and now it disconnects from sector 1 and connects to sector 2's network, which the sector 2 network considers the AGV as a new device. Now, the problem here is that when AGV connects to the sector 2 network, the DHCP server there simply just assigns the next available IP address without knowing what device or where it should belong. This creates risks such as whether the AGV is placed in the wrong subnet or it landed in the IT instead of the OT network. It could gain access to systems it shouldn't interact with, and etc. In a combined OT IT environment, this isn't just a configuration issue, it's a security risk. And that's where DHCP fingerprinting comes into play. So here in the DHCP section, in the client class, you can configure a client class for this devices that you want to allocate IP addresses by providing the name and assigning it on a global level or a subnet specific level. To select the subnet option, you need to provide the subnet from which you want to allocate IP and the specific range from which the IP allocation should be done, or you prevent the IP allocation from that specific range by selecting no and adding that range. And you can select the class type as IAC format, where you need to provide the condition in this condition box, or the template option allows you to provide the match values here in the match type, offset, length fields, and conditional statement and match value. So what happens is that when the devices like AGV tries to connect to a new network, if the client class is implemented there, the class tries to match the match values given with the device's MAC address. And when there's a match found, it classifies the device under a category. And when the specific pool range is given, the IP allocation from that specific pool will be implemented. So the device will get an IP address from the designated pool of the network that is allocated for, say, only OT device only. This implemented, the AGV is now placed in the correct OT network and given the right level of access and managed securely. This is how DHCP fingerprinting ensures that even moving devices are identified, controlled, and secured the moment they connect. far, we have focused on how DDI Central gives you control over your on-premise infrastructure. But modern manufacturing doesn't live on only on-premise. It extends to cloud. And DDI Central brings that visibility into the same console. Through what we call cloud observability, DDI Central integrates with Amazon Web Services to give you deep visibility into your cloud infrastructure, that is VPCs, subnets, instances, Route 53 DNS records, all pulled into one unified visualized console alongside your on-premise network data. Right now, cloud observability focuses on AWS for native cloud asset visualization. And in the near future, it will expand to support Cloudflare, Azure, Google Cloud, and other third-party platforms. So you'll have one platform to see everything, wherever it lives. Discuss the network segmentation and multi-site management. Now let's focus on one of the most critical layers in a converged IT OT environment, that is DNS security. In a manufacturing network, almost every action starts with DNS, whether it's a SCADA system accessing data, a workstation connecting to an ERP server, or an IoT device sending telemetry. It all begins with a DNS query. Because of this, DNS is also a key target for attackers. And in manufacturing, a compromised DNS system doesn't just impact IT, it can disrupt OT operations as well. In the Norsk Hydro case, the attack spread through the IT network using common methods with better DNS visibility that movement could have been detected earlier. Now let's look at how DDI Central helps address this problem. Now DNS firewall is always the first line of defense when it comes to DNS service. You can access DDI Central's DNS firewall by going through config option and selecting DNS firewall. Here you can add the domain which you want to block and the category under which it need to be blocked. And you can block the subdomains of the main domain you're giving by selecting the block subdomains. And the redirection IP you want to provide to redirect the resolution instead of the resolving to the domain's actual IP. And after adding, you can view two tabular columns, domains to be blocked, where the domains you added will be listed here, and subdomains block of the main domain will be listed over here. And in the view list, you can see all the malicious domains of each category here, which you can import for utilization. Or if you have your own existing malicious domains that you want to add here, you can simply click on import the CSV file, where you can import the domains as a CSV file here, which the application recognizes and adds it. In a manufacturing environment, DNS query patterns tell a story. Normal operation traffic looks a certain way, and when something is wrong and infected, such as an infected engineering workstation, a rogue device on an OT subnet making unusual queries, it shows up in the data. And that's where domain query analytics comes into play. So in the domain query analytics, you can have a visual understanding and a summary over the total number of queries per second, the total number of queries of the entire DNS server services, and in the graphical representation on timely and query-based results. And here you can, in the drop-down menu, you can select whether you want to view for hosted domains or non-hosted domains or block domains, the server from the specific server in which you want to view it. And even domain-specific query analytics is possible here. You can view the total queries received for the specific domain and from the IP address in which the total queries were sent, and the number of queries per IP here and queries per record, and record specific query analytics is also possible. So this is a drill down approach on a um, hierarchical specific. And these data can be imported in a PDF format and also in a CSV format, which you can use for data-driven decisions. And here, clicking on the forecast option, you can forecast the upcoming DNS query volume and query trends with the existing data that is here. Using AI ML model, DDI Central helps in analyzing the existing data and predicting the future trends based on the selective time interval that you're selecting here, the next 24 hours, the next 7 days, and so on. The same is possible for DHCP forecasting as well. Here in the list history, when you can view all the list history of the total DHCP service and IP specific list history, when you click on the forecast option, you can view the least trends and the IP trends of the next selected time interval based on the existing data. DD Central's query analytics gives network admins clear visibility into which devices are trying to access blocked or malicious domains, including how often those attempts occur. In a manufacturing environment, this makes it easier to quickly identify suspicious activity from an engineering workstation or even an OT device, trace it back to its exact location, and isolate it before it spreads. The dashboard provides detailed information such as query type, IP address, device details, and timestamps. Devices can be identified using host name or MAC addresses, making it easy to locate them physically on plant floor. Distribution denial of service, also known as DDoS attack, that occurs when attackers spoof IPs and flood DNS servers with small repetitive queries. Because DNS responses are larger than the requests, the servers unintentionally amplify traffic, overwhelm backend systems, and disrupt services such as customer Wi-Fi and etc. These attacks can be quickly detected using DDI Central's DNS query analytics, which highlights abnormal spikes in query volume. But to mitigate such threats, response rate limiting, also known as RRL, can be enabled on DNS servers to restrict the number of responses sent to any IP addresses. This RRL can be accessed in the config section and going into DNS option and selecting rate limit option, where you need to provide the details such as all per second, errors per second, prefix length of IPv4 and IPv6, and other details. And the clients you want to exempt from the mitigating responses by providing their data in the exempt client field. These data will be used to mitigate uh, large query volumes, and only specific clients will get the DNS resolution, thus securing the server from being abused by the attack and preventing downtime. DDI Central uses ManageEngine Cloud DNS thread feeds to automatically update and strengthen DNS security across the manufacturing network. This provides real-time protection by continuously adding the latest threat intelligence without the need for manual updates. In manufacturing environments, many OT environments cannot be easily patched or updated. In such cases, DNS level security acts as a strong backup layer, blocking access to malicious domains even when the device themselves cannot be fixed. Most advanced attacks in manufacturing environments are often silent. For example, DJ-based malware generates thousands of random domain names to communicate with attackers, helping it avoid traditional security defenses. In an OT environment, this kind of threat can go unnoticed for weeks, quietly stealing data or preparing for a larger attack. DDI Central's anomaly detection engine is built for detecting these hidden threats. It uses a two-layer approach, built-in rules to catch known network anomalies, and the Soho's Zia AI engine, which uses machine learning to identify advanced threats like DJI activity, DNS tunneling, and unusual behavior from devices. Combining with features like DNS firewall, analytics, threat intelligence, and rate limiting, this creates a strong and proactive DNS security system for manufacturing networks. And that brings us to our conclusion. Today, we have looked at the full picture of IT/OT convergence. We have started with how Industry 4.0 has transformed manufacturing networks, connecting systems that were once separate. We looked at the reality of today's threat landscape. We saw a real-world example of North Hydro incident where a single infected email led to a ransomware attack that spread through the IT network. We then explored how DDI Central helps address these challenges by providing centralized management, better network segmentation, and full visibility. At its core, DDI is not just about managing IPs. In a modern manufacturing environment, it plays a critical role in ensuring security, visibility, and uninterrupted operations. It forms the foundation that supports smart factories, IIoT systems, and digital transformation efforts. Thank you so much for spending your time with us today. It genuinely means a lot, and I hope this session gave you a clear picture of the IT/OT convergence challenge and how DDX can help you navigate it. Right after the session, you will be directed to a downloads page where you can kick off your 30-day free trial. We also have a live interactive demo available for you to explore at your own pace. And if you have any follow-up questions, reach out to us at ddasupport@manageengine.com. Our team is always happy to help. This is your host, Vikramaditya, signing off. Thank you.